Okay, so
No,
if you
like,
have a
I mean,
proposition you don't know if it's true or
there's
not, it's called a
something else.
conjecture.
To prove that they have to be
Okay.
Okay, so
conjecture. So
All right.
we have
that is a requirement.
set a plus b over 2 equal and root of ab equals m.
A plus b over 2 equals what? N.
Yeah, and then just root of ab, just root of ab is m, just to help with notation.
Mhm.
So we get that ab equals m squared. So possibly we could find some find an example, like find a construction for each ab and n, such that you can always get uh n minus m squared.
Oh.
Wait, hold on. Okay,
There,
so
there might be a relation between.
I have an idea. So assuming you have like take the factors of A, B, and so the factors are
Wait. Alex was like, wait, hold on.
I have an idea. So if you have, assuming you already have a nice pair, then they're like equal distance from a number, which is half of the sum. Well, they're equal distance from the arithmetic mean, so you can represent them as the arithmetic mean plus something and minus something.
Oh.
And when you multiply them, that's a difference of squares. Nice. And the result has to be a square as well. So that is a Pythagoras problem. I don't know.
Sorry, Alex. Sorry you had to say nice yourself. We should have said nice for you.
I don't like nice. Nice is bad. Okay, so we have properly, we have nice. What else do we have? Okay.
Oh, so you're saying like it's n plus x
Yeah.
and n minus x. That's C and D. Is that what you're saying?
Yeah. And then you
And then you
times
get
them together.
n squared minus x squared equals m squared.
Yeah. That looks very much like Pythagoras.
Oh.
Also, if you rearrange it, it's symmetrical. So I'm thinking maybe we can use m as the deviation instead.
Oh, so n
Of
squared.
the other pair. So now n squared minus m squared equals x squared. And then we do something with that because
Oh,
I'll try it myself.
wow. Does anyone else feel like he solved the problem but didn't realize it?
What? I haven't tried it. I don't know myself. Oh my god, this is smart. So 3
almost
27. Yeah, because we have n minus. We do 3 and 27, then the middle thing is 15. 15 plus minus 12. Oh, that's just the 3, 4, 5 thing. Okay, we'll reduce this down.
What?
No, we don't reduce this. No, we don't.
He's a prodigy.
It's pronounced prodigy.
No, it's prodigy. I don't know.
Prodigy.
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 Strategy.
Strategy.
No, someone kept on saying it, and now it's like everyone.
Okay, so you're saying you got this. You need to find and like, you're trying to prove that there always exists one, yeah?
Yeah.
Okay, which amounts to proving that the x exists.
Yes.
Yes. And what did you do?
Wait. What?
So you're trying to prove that anytime you have two positive integers whose two different means are positive integers, there's always.
Let me think about this. So we have.
Okay, more time to think.
Yeah, I need to think.
Yeah, so we're looking for another pair of integers with the same property, okay? And we don't care about the order of the pair.
A plus B.
Hold on. So Crystal is saying that you have one x that comes from the fact that a and b itself, right? So you have basically one x is equal to b minus n, right?
Yeah.
Yeah. Assuming a is bigger than b, I mean b is bigger than a, then your x It's b minus n. I guess it's also equal to n minus a.
How? Zero n minus b plus.
Hmm.
Plus.
Okay, and the idea was to do what? Swap m and x.
Yeah.
Swap m and x.
Wait, so we're trying to prove x exists.
Well, so I guess what Crystal was saying is there is an x that exists just from the a and b, right?
Yeah.
And then we're trying to prove another x exists.
Wait, x. So we're replacing m.
And then the claim is if x and m are different,
Yeah.
we can try to replace them with each other.
We know for a fact that m is smaller than n.
M is smaller than or equal to n, yeah?
Yeah. So let's see, if m is if the difference between m and if m equals n, then what happens? M equals n, then x is 0. X squared is 0. Therefore, x is 0. Therefore, the numbers are the same, so that doesn't work. So that can't possibly happen. So m must be strictly less than n.
Why can't x be 0?
Because if x is 0, then a and b are both n. And they're the same, and it says distinct. So just,
Oh. Okay, so we need a distinct pair, so that means x is not 0, right?
yeah, so m is strictly less than
And m is strictly less than n. Yeah?
If m is strictly less than n, then n minus m will be positive.
Mm-hmm.
So that works. And m plus n is obviously positive because of.
Yeah.
But is it obvious? What's that? Yeah, we could. Yeah, because x is given that it's less than. They're also.
Hmm.
I'm gonna eat cucumber because cucumber equals brain.
Yeah, so how do we swap m and x, Crystal?
N squared minus x squared equals m squared. N squared equals m squared plus x squared and n squared minus m squared. That's how I would say it. But the
Very good. Conspiracy.
We can just construct new solutions for n and n plus n.
n minus
store
m.
bought cake because it's my grandma's birthday. Oh,
So
yes.
n minus
So I was
m,
eating cake at school.
m plus m is
Yeah.
as
Yeah,
c and d.
Yeah.
Yeah, because I ate it very fast before you came back
Ah.
from canteen.
So what does that
Same
mean?
store-bought cake they use to make the dessert.
Okay, so we have an idea from Crystal that says let C and D be n minus m and n plus m, yeah?
Yeah.
Alright, so obviously they have the same mean, yeah? N. Yes?
Yes.
Alright. And obviously they're different. Yes? And then what's the geometric mean?
It's once again, it's just n plus n minus n squared minus m squared equals
X
equals
squared.
x because like, we rearrange
Yeah,
the form equation.
Mm-hmm.
N squared minus m squared equals x squared. If we square root that, m square root of
Hold on. So wait.
yeah.
Okay, and then what?
Yes.
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 X is integer
Why is X an integer?
because if x wasn't an integer, then n plus x and n minus x would not be.
10 plus X and n minus X. Whoa, no, this is where does X come from now? Is it just
X just comes from like A and B.
is this X?
Yeah.
Okay, so let's see. What are we going with this?
Yeah, because n minus A and what happens to that table? Look, no, step out.
What is one?
So I guess you're given A, B,
All this
and N, I guess. And then you're also given that N squared equals M squared plus X squared. We construct
Yeah.
another solution. That also
Yeah. So it might be good to finish this with an example to really see how it works, but
okay, so
uh,
3 times 3 and wait no.
So 3 and 12.
so
Okay,
3
so
and
we have
12.
like
So
so
wait,
we
no,
use
3 and 12 don't work. Never mind.
no. Like
3 and 27. We're going big.
okay.
3 and 27. So the
So we had
arithmetic
1 and
mean is
9 as the
15.
base case.
What? The geometric mean is 9. So that's nice, I guess. Yep.
Nice.
Very nice.
Yep. And then if we were to do the other construction, we'd have 15 minus 9 and 15 plus 9, right?
Yeah.
Yeah.
So we go
3 and
26,
27 and 15 and 12.
7. Yeah? What
No,
am I
it's
doing?
not 15 and 12. It's 5.1.
What am I doing?
The first six, which gives us 12.
No, 20.6.
Yeah. It's 12.
Why am I
The construction.
bad at arithmetic?
Does that work?
Yeah.
What's the geometric mean of 6 and
24
24?
plus 6 equals 36.
It is 12, yeah.
No, it's 30. No, it's 6. 24 times 6.
Alright, does
Can't
this
do maths today. It works. Okay, so I think the simplest case should be 1 and 9. Because the simplest Pythagorean triple is 3, 4, and 5.
Hmm.
But
What happens if they were the same number? What happens there? You get the same one back?
they're the same number, I'm pretty, yeah.
You get like a 0 and 2.
Wait, hold on. If they're the same number, then x is 0.
Yeah, you get a 0 and a 2 times.
Get 0 and that number.
Like this, yeah, you get 0 and twice the number, right?
Yeah. Yeah.
Alright, well let's try to go through the proof. Or did you want more time to think about the proof?
I think the proof comes down to making everything integer.
Yeah, so I guess in the proof, well, what do we need to show? What have we not yet proved?
I don't know.
So we know that Hmm? Yeah, so n squared is just a plus b on 2 squared, right? And you're minusing ab.
Wait, what?
That's gonna give you an integer, a square of an integer, right?
Mm,
Yeah. Yeah, so you can prove that x is always an
I
integer.
guess Dragon.
Okay.
It's MS Paint.
Alright. Do you have to prove something like c is not the same as a?
C is not the same as A. That is true.
Because you need now we have a nice pair, right?
Okay, so we need to prove that
Is
in
it
any Pythagorean triple, there shouldn't A and B shouldn't be the same, and that's obvious because yes. And if we prove that, we prove this.
I feel like Alex thinks with speech, and then he reviews what he's saying with his mind.
What is it?
How do we replace you with Alex in your turn?
Okay, so we'll finish this off after
Am
eating
I
something,
alive?
okay?
So to
Okay,
prove,
what remains to be proved, yeah? So we have A and B, right? They're different.
so if X and M are the same, then it doesn't work because A equals C and B equals D.
So what are you saying?
If X equals M, then that doesn't work.
So if x equals m, what happens?
Then A equals C and B equals D because they're both n minus X and M plus X.
Alright, so you're not really, so you're explaining something which makes sense in your head. Okay, but where does this begin?
We must find that there's another nice pair.
Yeah. So it starts with A equals C, not with x equals m, right?
If A equals C, then X equals M.
Okay, so if A equals C, how do you get x equals m?
A equals C, so therefore N plus X equals N plus M. X equals N.
N plus.
Oh, so you're saying, okay, because A is n minus x, right?
Yeah.
And C is n minus m, yeah?
Hmm.
So therefore x equals m, yeah? What's wrong with x equals m?
Well, okay, so it's not possible for X to equal M because then N won't be an integer. Because if X equals M, then N is the square root of X plus, wait, hold on. Okay, so at the bottom, right, we have X squared plus M squared equals N squared.
Okay.
X equals M, then it's X squared plus X squared equals N squared. Then it's 2X squared equals N squared. Then it's root of 2X squared equals N. And then it's root 2X equals N.
Oh, so n
That's
squared
not
can't be 2 times the square, yeah?
Yeah,
Oh,
that's not what.
because 2 is not a square. Yeah, so this can't happen because there's an odd number of 2's dividing the right hand side, there's an even number of 2's dividing the left hand side, right?
So we know that if we take M, then that will be a different. We will get different A and C.
Mm.
We know that A can't equal D and B can't equal C because M and X must be positive.
Oh, are people satisfied with this as a proof?
Yeah.
Yeah? What do you think, everyone? Crystal, happy with this? Alright, let us move on.
Can I do 3?
Question 3.
Or you
Wait,
just want to...
Kevin just added